This clip is the apex of the entire module and should solidify your understanding of MPLS Layer 3 VPNs as a complete solution. Let's perform a detailed verification of our design. We left off on R10 after reviewing its BGP configuration. I've pulled up R10's routing table entry for 192.168.11.0/24, which is R11's LAN prefix. The next hop is the PE of R6, and there is no associated MPLS label. Remember, our customer devices like R10 and R11 have no idea MPLS is even being used by GlobalMantics. To them, it's just a standard BGP connection. Let's head to R6 next, which is the ingress PE. In the previous clip, we checked R6's BGP table and saw the iBGP learned route of 192.168.11.0/24. When you're tracing LSPs, I recommend focusing on the routing table and the structures that rely on it, like the fib and LFib. Inside of the customer VRF, we have an iBGP next hop of 10.0.0.8 in the default routing table, which is the egress PE of R8. MPLS is required for this destination, and label 8018 is pushed first. Next, we need to know how to reach 10.0.0.8, so let's perform another routing lookup. This should be performed in the global routing table and not the VRF. We have a /32 match for this destination, which is learned via OSPF. In the previous clip, we saw a metric of 31 as the IGP cost to the BGP next hop, and here's the proof. What label should be pushed onto the stack? If a route is learned through IGP, we should push an LDP label, so let's consult the lib for 10.0.0.8/32. We have two remote labels, one from R1 and one from R7. Which one should R6 choose? The routing table says the next hop for this prefix is 10.6.7.7, and let's pretend we didn't know which device this was. We can check our LDP neighbors to see which addresses are bound to each device. Searching through the bound IPs, we see 10.6.7.7, which is associated to 10.0.0.7 or R7. That means we must use the remote label we learned from R7, since we'll be sending traffic in that direction. If you didn't write it down, that label was 7016, so our label stack is currently 7016-8018. Cisco IOS makes it easy to verify the entire label stack by checking the fib. Because an IP packet is received from the customer, R6 consults its fib, which performs the imposition. Let's see what it says. The topmost LDP label is 7016, and the bottom BGP label is 8018, which is correct. Using this single ceph command on the ingress PE is helpful in production. Let's move to R7 next. We'll move more quickly through all the intermediate hops in the interest of time. When R7 receives label 7016 on ingress, it swaps to 9005, making the label stack 9005-8018. 9005 is R9's local label for 10.0.0.8/32, the BGP next hop. 8018 is R8's local label for 192.168.11.0/24, the VPN destination. Next, let's check R9's LFib. R9 is the second to last hop in the path, and therefore performs PHP to remove the topmost label. This will expose 8018 directly to R8, which makes sense because R8 is the egress PE. Let's see how R8 reacts. R8 was directly exposed to 8018, its local label for the VPN prefix, so that's the label it looks up in the LFib. Outbound, there is no label, which makes sense as our customer is not running MPLS. The prefix is no longer R8's loopback, but is our final destination of R11's LAN. The V in square brackets means VPN route, indicating that this isn't in the global routing table. The next hop is R11, the CE device, and this completes the R10 to R11 LSP. Let's head to R10 to test it. I'll use traceroute to target R11's LAN sourced from our own LAN allowing us to validate our LSP tracing skills. The first hop has no MPLS encapsulation, as this is the PE to CE link between R6 and R10. The same is true for the last hop between R8 and R11 at the other end of the VPN. I won't read all these labels out loud, but you can clearly see that the traceroute matches the labels recorded in the diagram. Remember that LSPs are unidirectional, so let's gain some additional practice by tracing in the reverse direction starting on R11. We'll move a bit faster this time. R11 has a route to R10's LAN via R8, and this is not MPLS encapsulated as it's a PE to CE link. Let's check R8 next. We begin by checking the routing table, and R8 has an iBGP learned VPN route for this destination. R6 has allocated a label of 6018 and mapped it to 192.168.10.0/24. R8 will push this label onto the stack first. R8 then performs a recursive routing lookup on 10.0.0.6, the BGP next hop. This yields an OSPF route with a next hop of R7. Notice that R9 isn't in this LSP at all. That's due to our asymmetric OSPF cost adjustment described earlier in the course. Remember, LDP-based LSPs always follow the routing table. Let's issue a highly targeted lib command to see the label learned from R7 for this particular prefix. I'm skipping a minor step because I happen to know that 10.7.8.7 is bound to the LDP router 10.0.0.7, but you can always verify that with show MPLS LDP neighbor. We see label 7015 here, so this is the LDP label pushed onto the stack, giving us 7015-6018. We can confirm that by checking the fib for this VPN prefix using our show IPsef shortcut command. As expected, we see 7015 first, followed by 6018. Let's head to R7 to continue tracing. R7 expects label 7015 inbound for prefix 10.0.0.6/32 and performs penultimate hop popping. This exposes the VPN label to R6, which is the next hop. Again, thanks to our OSPF cost adjustment, this LSP is one hop shorter than the previous one. Let's head to R6, the egress PE for this LSP. Label 6018 maps to the prefix 192.168.10.0/24 that exists inside of the customer VPN. The next hop is R10, and there is no MPLS encapsulation outbound. As a final check, let's head to R11. We'll use traceroute just like we did on R10, except we'll swap the source and destination IPs to test the reverse path. Performing a quick comparison with our diagram, we see that everything looks correct. I strongly recommend you make manual LSP tracing part of your regular MPLS study routine. After a few hours, it will become second nature. Once you complete the manual steps, use traceroute to check your work and build confidence.